All right, so today we're going to dive into one of the most powerful and honestly one of the most fundamental ideas in all of programming, and that's functions. I mean, they're pretty much the building blocks of almost everything you see on your screen. If you're just getting your feet wet with coding, I bet you've had this feeling. You figure out a piece of logic, you're proud of it, and then maybe 10 lines later you realize you're writing the exact same thing all over again. It's that classic copy and paste moment, right? And look, it works in the short term, but it just feels messy. And as we'll see, it can cause some pretty big problems down the road. And yeah, this is exactly why it's such a big deal. We're not just talking about saving a few keystrokes here. This quote really hits the nail on the head. Every single time you repeat code, you're basically opening the door for more errors. Think about it. A tiny typo in one spot, well, now it's duplicated everywhere, and suddenly you've got this web of bugs that's an absolute nightmare to track down. So what's the fix? How do we solve this repetition problem? Well, thankfully, programmers figured out a really elegant solution for this a long, long time ago. It's this idea of wrapping up a piece of code, giving it a unique name, and then just calling on it whenever you need it. And this awesome concept? It's called a function. And really, when you get right down to it, a function is super simple. It's just a block of code that you give a name to, and it does one specific thing. That's it. Kind of like having a toolbox, you know? You've got a hammer just for nails, a screwdriver just for screws. Well, a function is like a specialized tool for one specific piece of logic. I love this boss and worker analogy. It's perfect. So think of your main chunk of code as the boss. Now, the boss doesn't need to know every single tiny detail of how a task gets done, right? They just need it done. So what do? They delegate. They call on a specialist, that's our function, and just say, hey, I need you to go handle this. The function, our little worker, goes off, does its job, and then reports back with the results. And this keeps the boss's desk, our main code, super clean, organized, and focused on the important stuff. Okay, here's another great way to think about it. A function is like a recipe. When you write a function, you're just writing down the instructions in a cookbook. All the steps are there, but no cake is being baked. Nothing is happening yet. The recipe is just sitting there. It's only when you actually decide to use it, when you call the function, that the oven turns on, the steps are followed, and you actually get a cake. All right, so we've got these reusable recipes, which is awesome. But what if you want to customize them? I mean, your cake recipe is fantastic, but what if you want a chocolate cake today and, I don't know, a vanilla one tomorrow? You can't use the exact same recipe for both, right? You need a way to pass in different ingredients. And this brings us to a really key idea. A function that just prints hello is fine. It's useful, I guess. But a function that can say, hello, Sarah, or hello, David, now that's way more powerful. So the big question is, how do we give our functions that specific information they need to really do their job? And this is exactly how we do it. If you look at the code here, see inside the parentheses right after the function's name, you've got name, age, and shoe size. These things are called parameters. You can think of them like labeled parking spots, just waiting for some information to pull in. The function is basically saying, hey, I'm ready. I'm expecting a name, an age, and a shoe size. And boom, here's the payoff. When we actually call the function, we give it real values. Chris, 34, and 9. These values, which are often called arguments, they are the cars that pull into those parking spots we just talked about. The function then grabs that specific data and uses it to run its code, giving us this totally custom output. See? It's not just a generic template anymore. It's a dynamic, personalized action. This whole idea leads to one of the most important concepts in all of programming, and it's called abstraction. It sounds complicated, but it's not. It just means that once a function is written and you know it works, you can treat it like a black box. You don't have to worry about how it works on the inside anymore. You just need to know what to put in and what you're going to get out. Honestly, this is the secret weapon for how programmers build crazy complex software without getting totally lost in the details. Okay, so up to now, our functions have done something, like print a message on the screen. But what if we need a function to do some math and give the answer back to our main program? We're not talking about just showing the result to a person. We need a value that our code can actually use for the next step. Right. Like, imagine you have a function that calculates sales tax. You don't want it to just print the tax amount. That's not very helpful. What you really need is that number, that tax amount, so you can add it to the original price and get the final total, right? So let's take a look at this example. We've got a function here that's built to add up all the numbers in a list. It goes through each one, keeps a running total, and then you see that super important keyword at the end, return? That is the magic word. The return statement is what officially sends the final, calculated value back out of the function. Yeah, you can think of the return keyword like the function handing a package back to the boss, back to the main program. It's the official way for the function to say, hey, my job is done, here's the result you asked for. And then your main code can grab that result, maybe stick it in a variable, and use it for whatever it needs to do next. All right, let's pull all of this together. We started with this problem of messy, repetitive code, right? And we've seen how functions can fix that by taking in information and returning results. So now let's talk about the real game changer here, the real power that this whole approach unlocks. This right here is the magic. You put in the effort to write and test your function one time, just once, and then you can call it from literally anywhere in your program, as many times as you want with totally different information each time. It's this beautiful principle of define once, use many, many times. And the benefits you get from thinking this way are just huge. First off, you get to say goodbye to all that repetitive code, which right away makes your programs more reliable and way easier to fix. Your code also gets so much cleaner and easier to read because all the messy details are tucked away inside these neat little functions. And maybe most importantly, you start building this library of reusable tools that will save you a ton of time and effort on whatever you build next. So at the end of the day, a function is way more than just a bit of code syntax. It's a way of thinking. It's about looking at a big, complex problem and learning how to break it down into small, manageable, and reusable pieces. It's the absolute foundation of pretty much all modern software. So the real question I have for you is, now that you understand this tool, what are you going to build with it?